guys, again. So today we're going to be talking about lipids. Okay, so lipids have a lot of functions in the body. We're going to start by going through a few of them. One is that they are the structure of the cell membrane. So this is super essential to each and every cell that you have. So it's very important to have lipids to take care of this function. Okay, and these functions are specific to lipids, so don't use them for any other macromolecule. Next, they are heat insulators. So that is pretty insulators. That's pretty self-explanatory. They insulate. So, for example, if you get like shocked by electricity or something, it'll be able to insulate the electricity, because they're good at heat insulation. That's why polar bears, remember, polar bears have a lot of fat under their skin so they can insulate in Antarctica. Okay, next we have, what is another function of lipids? It is long-term energy. So your body needs backup energy when it runs out of carbohydrates. It's gonna start using your fat. So that's very essential, especially for like animals that like go hunt and stuff. Birds, super essential. Okay, so let's talk about the main types of lipids. So we have first we have fatty acids, and we have the glycerol. So obviously these are made of C's and H's and O's. So a fatty acid is going to look like this. The general formula is CH3. It's bonded to a CH2, but we don't know how many CH2s you have. So you put it to the N, and then you have a carboxyl group. Carboxyl is a carbon that has double bond to the oxygen and has one bond to the OH. Okay, that's basically a fatty acid. Next, we move on to glycerol. Glycerol has a nice shape. It's easy to remember. Hydrogen, carbon, 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 hydrogen. On one side, there's OHs. One side, there's H's. See? What a beautiful and easy to remember molecule. Okay, so these two go together. Do you know what they form? Well, I shall tell you. They form something called a triglyceride. Okay, so what is a triglyceride? It is 3 fatty acids plus 1 glycerol. So if you watched my other video, I talk about condensation and hydrolysis. So condensation is when you go from mono to a poly. Well, when there's di in the middle, we know that. So in a triglyceride, you go from having 3 fatty acids and 1 glycerol to having a triglyceride. So how does this happen? Well, we're going to have 1 glycerol right here. I'm going to draw it. HCCCH. We have H, OH, OH, OH. And what are we going to have over here? We're going to have our 3 fatty acids. So we're going to start with our carboxyl group because it happens this way. And OH, here we have a C, CH2 to the N, and CH3. So what is this again? Our fatty acid, yes. Okay, now we have another carboxyl group. Whoa. Right now I'm drawing another fatty acid. CH, and these are described as chains. So if they tell you describe this, you describe it as a chain of C's and H's. And here we have another carboxyl group because you have another fatty acid, OH, CH2, and CH3. All right. So what is going to happen here? And also, as I told you last time, when you do and perform a condensation reaction, you yield water as a byproduct. It's very important to remember when you're doing this condensation reaction. So what's going to happen here is you're going to have these two bond together. These two are going to bond together. Each fatty acid will have its little buddy, part of the glycerol. So remember, this one's this guy's buddy, this one's this guy's buddy, this one's this guy's buddy. So these buddies are going to are going to actually come together and form a kind of bond. So do you know what the bond in lipids is called? Okay, so what's happening here is we need H2O. This one yields H2O, this one yields H2O, this one yields H2O. So how many H2Os did we just yield? 3. So 3 H2Os have been yielded by this lipids condensation reaction. Okay, so this bond in lipids, so here we're using this, we're using H2. So, 2. Okay, so we're left with 3 O's. So where are those O's gonna go? We have to remove these two. Yes. Okay. So we're left with the O of the carboxyl. I'm just gonna move these a little bit closer. But how are we gonna connect them? We're missing some things here. So these leftover O's are gonna go in the middle, and they're gonna connect the carbons. Wow, isn't it perfect? It's absolutely perfect. And then we have plus 3H2O. That's it. But one last thing for the condensation. This is called a ester bond. So last time in my video, I told you that it's called a glycosidic bond. But that only pertains to carbohydrates and polysaccharides and monosaccharides and disaccharides. Okay, so that's very important to remember. Ester bond. So what is it called? An ester bond. Yes, okay. So now if we want to go in the opposite direction, also known as hydrolysis, we go from 3 H2Os, we add it to a triglyceride, which is this one, and we will result in glycerol and 3 fatty acids, basically. Hydrolysis. That's it. Now, one last thing, which is the types of lipids. Okay, so we know that lipids go into fatty acids and glycerol. That is the actual molecules. Now, what if we're talking about the structure of a lipid? Now, forget about the glycerol and fatty acids. Let's think of a triglyceride. Let's think of this structure right here. So there's 2 types of shapes that it can be. It can be unsaturated. It can be saturated. I'm sure you've seen this on a nutrition label or something like that. You've heard of it before, I'm sure. So, saturated means that it is a linear type of thing. And actually, yes, I think it's linear. And it has all of the H's. So let's say H, 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 and here there's probably C's and H's, H and H, okay? But in the unsaturated, we have double bonds. So we'll have a double bond here. That means we lost an H. So to compensate for that, the C will bond to the other C. Now that explanation isn't really important, but it's important for you to know that there are less H's in an unsaturated lipid, causing double bonds. So double bonds characterize an unsaturated fat. Depending on the number of double bonds is what you will classify your fat as a mono unsaturated or a poly unsaturated. There's no di. You go straight from mono to poly. So mono would be 1 double bond, and poly would be more than 1 double bond. Okay, now it's going even deeper than this. So when we're talking about poly or mono, there's two types. Even more types, guys. Gotta keep these all in mind. There's cis fats and there's trans fats. Okay. So we characterize the double bonds over here, and we talk about the unsaturated and saturated because there's all the H's are present and not enough H's are present over here. So we're lacking H's. So here, when we go classify them into mono and poly, we go even further into cis and trans. Cis looks like this. Now, I want you to notice something about this. Forget about everything that we said before about all the double bonds, and just notice the structure of these molecules. Oops, my bad. I know what you're thinking, and that's correct. Over here, the H's are on the bottom side. Over here, the H's is one up and one down. Yes, that makes a huge difference in the classification of cis and trans fats. Cis, don't get me wrong, it can also be like this. But the H's must be on the same side, and the trans can also be like this. It's still classified as a trans fat, but it's like this. So we can see the differences. They're starting to come. Okay, so now, what really is the difference between cis and trans? Cis is naturally found in nature, and you might have to distinguish between these two, so keep these facts in mind. So it's naturally found in nature, a very important thing. And trans is usually man-made. Next, we have the structure. So because of this H structure here and this H structure here, the trans fats have a linear structure. Whoa. Linear structure. And the cis fats have a bent structure. What do I mean by bent? Is that cis can go like this. They can bend. That's why this leads us to our next fact, where they are liquid at room temperature. And can you guess trans fats? Yep, they are usually solid at room temperature. Very important to keep in mind. And yeah, that's about it for facts. Not facts. Yeah, if you have any questions, please do let me know. Yeah, thanks for listening.